Hi, everybody. So, you'll want to pause this and read this. So, what's going on is we are doing a hypothesis test that's going to connect to confidence intervals, and it's a two-tailed test because that's not equals. So that right there, our p-value of 0.072 will get split and shared. So I need that information over here. And the question that we're trying to see is the population proportion going to be contained in the confidence interval, and specifically the 90% confidence interval? And let me see if I can explain why it won't be. So when you're dealing with a two-tailed test, you draw your p-hat twice, both equidistant from the center. So if this is 0.5, which is not, it's 0.75, but pretend it's 0.5 for just a moment, and this was 0.8, well, that distance is 0.3, so you'd also go 0.3 that way. And then this gets a p-value of 0.036, and this gets a p-value of 0.036. These are accurate, 0.036s. Now, a confidence interval is about a distance, okay? And so if you have the 90% confidence interval, what it does is it takes the standard deviations from the population proportion. It takes the standard deviation from the sample proportion that you're looking at, and it talks about the distances. And so it gets a distance to the right, margin of error, distance to the left, margin of error, and it takes a look and sees, well, I'm centered at p hat, how far to the left, how far to the right do I go? So here's the thing. 90% splits this into 45% and 45%. If this is 0.036, I'm going to travel all the way here, a distance and area of 0.036. The distance here is going to be 0.45. And so what happens is you take 0.036 and you add 0.45 and you get 0.486. Now, the distance from pi to infinity is 0.5. If I travel a distance in terms of percentages of 0.486, I'm landing about here. I do not cover pi. Okay? Now, if I do the 95%, then this would be 47.5, and 47.5 and 0.036. Well, we're now at 0.511. So the 95% confidence interval would contain it. Okay, now I've got a problem that I need to answer that's connected to that. So here we go. This is number 17. And on number 17, we have a one-tailed test, and our p-value is 0.08. So I don't split the p-value. I'm going to travel back over here, and I'm going to draw that normal curve again. And that's greater than, so it's a right-tailed test. So this area is 0.08. Now, it's going to ask us what's a reasonable confidence interval going to be if we're talking about the 95% confidence interval. And right here, we know the value is 0.5. Now, 0.08, and let me draw this up. Remember, this is where our p hat would be sitting. And we're going to have half of the 95% confidence interval over here and half over there. So this is going to be 0.475, 0.475. Now, if I add this and this confidence interval will cover our hypothesis value. So let's travel back over and see which one of the intervals actually covers and contains the 0.5. Okay, so if you look, we have an interval of 0.08 to 0.16. That doesn't cover 0.5. We have 0.4 and 0.6. That covers 0.5. Doesn't cover, and the other one doesn't cover. So this is the one that covers the 0.5. So this one is fitting here. Now the question becomes, hey, wait a minute. Isn't 0.08 moderate evidence to suggest that we reject the null? And that is correct. There's a problem with using the approach of moderate, strong, very strong, in that confidence intervals and hypothesis tests are supposed to work together. And so if your confidence interval is 95%, then your threshold you should be using is 0.05. And what I mean by that is if you take 0.05, and this is larger than 0.05, this means you fail to reject the null. There isn't any of this sort of soft difference anymore. So 95, you're looking at 0.05, that's larger than 0.05. You are failing to reject the null. You are keeping the null. And so this is the one that supports this. So if this was the 99% confidence interval, our threshold would be 0.01. And this is larger than 0.01. So this would be supported as well. So the null hypothesis would be supported. You are failing to reject the null. Now, if this was the 90% confidence interval and our p-value was 0.08, well, the 90% confidence interval threshold is 0.10. So this is smaller than 0.10. So you would be rejecting the null and you would be operating as if the alternative was correct. So it's important to understand that when you start dealing with confidence intervals, the alpha, remember confidence level plus alpha equals 1, the alpha becomes a strict threshold. It's not soft where a little bit above, that kind of thing, where you had the moderate and you have the strong and the very strong. It becomes a definitive line. All right. Hopefully that helps. All right. I will talk to you guys.